Okay, ladies and gentlemen, welcome to the notes for your McGraw-Hill Algebra 2 textbook. These notes will cover Chapter 0, Section 1. There will be 2 videos for this section of Chapter 0. We are not going to be covering the entirety of Chapter 0 in this class, only what I feel is necessary to review before we go into Algebra 2. So, Chapter 0-1, Section 0-1 is entitled Representing Functions. It covers the idea of a relation and the various ways that we can represent a relation, as well as domain and range, and then how to tell when a relation is a function. All of this information should be information that you already know from Algebra 1. But we're going to go through it again anyway. So here we go. A relation is a set of ordered pairs. When we say an ordered pair, we're talking about a point, x comma y. It consists of 2 different number sets, the domain and the range. The domain is a set of all of the x coordinates of your ordered pairs, or the input of the relationship. Your range consists of the y coordinates of each point, or the output of the relation. So the first thing you could be asked to do is you could be given a list of ordered pairs and asked to state the domain and the range. And that is extremely simple to do if we have a domain and a range consisting of ordered pairs. The domain simply consists of the x coordinates, these numbers. Many teachers require you to write them in order from smallest to largest. I do not require that, but they should be listed as a set. So we start off with a curly bracket or a brace. And then we list the numbers. I usually list them in the order that they appear without any repeats. So notice how I'm skipping over the second -2 because they are the same. Okay? So we do not repeat values. And we'll not do that in the range either. Okay, when we list these sets out, we are never, ever, 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 ever going to repeat. The range consists of the y values. That's the second number in each ordered pair. So same deal, those numbers right there. We're going to list those in order. It doesn't matter to me whether that order is smallest to largest or order of appearance. I'm going to do order of appearance. And again, we do not repeat. So that second 5 would be ignored. That's how we do the domain and range. Now, there are 5 different ways to represent a relation. Now, this particular relation is listed as a list of ordered pairs, -2, 5, -3, 4, 5, 3, 4, 2, -2, 1, and 0, 5, which means it doesn't actually have all 5 representations. It will not have an equation. Okay, this one does not have an equation. So we'll go through how to write that set of ordered pairs in each of these other ways. Again, this should not be new information. You should already know this. First step would be an XY table. We've all seen those before. All that we're doing there is taking each ordered pair and rewriting it in a single row within the table. So -2, 5, -3, 4, 5, 3, 4, 2, -2, 1, and 0, 5. Just like that. You can make your table as fancy or as simple as you want, but each row should represent one of the ordered pairs from your relation. Mapping is a little bit more difficult than that, but not a whole lot. Basically what we have is we have the domain and range represented as bubbles, and we are going to list each point by writing the domain value, -2, and the range value, 5, and then drawing an arrow indicating that -2 is related to 5. That's this first point right here, -2, 5. And we're going to do that for every point. But just like when we write out the list of ordered pairs, we are never, ever going to repeat a value. So -3, 4, 5, 3. Notice how since the 5 is in the domain this time, it does technically get repeated in the representation because it's not in the same set. It's in the domain, not the range. 4, 2. -2, 1. So notice I already have a -2, so I'm just going to draw a second arrow from that -2 down to the 1. and then 0, 5. So I draw the 0 and arrow up to the already existing 5. A graph would mean that we are to graph these points. We would not connect them, just graph them. So we have -2, 5, which is left 2, up 5 from the origin. -3, 4, which is left 3, up 4. 5, 3, which would be right 5, up 3. 4, 2, which is right 4, up 2. -2, 1, which is left 2, up 1. And 0, 5, which is right or left 0, up 5. Notice I'm not connecting those points. I'm simply indicating that that point is part of this relation by drawing the point at the appropriate location. And as I mentioned before, this relation does not have an equation. In fact, most discrete relations that aren't connected on the graph, don't have an equation. I'm not going to say all, because sometimes they do, but most of the time they don't. And we're not going to often deal with an equation in this section, but when we get further into Algebra 2, we will be dealing with continuous relations, so we will need to understand that an equation could be used to represent a relation if it's not a function. Okay, final slide for this video deals with the vocabulary of the word function. Okay, so a function is defined as a relation in which each element of the domain, that's your x values, is paired with exactly one element of your range. Range, again, is your y values, your output. Okay? This means you cannot have any repeated x values in your relation. Okay, so if we look at a list of ordered pairs or a table, we're looking for repeated x values. Can't have it. Okay, for a graph, if we can run what's called the vertical line test. It says if you can draw a vertical line, that is a line that goes straight up and down, that's vertical, okay, on the graph of your relation and have it intersect 2 or more points, then it is not a function. Not a function. Okay, and we would say that that fails the vertical line test. In a mapping, the way that we tell in a mapping is there cannot be 2 arrows beginning at the same place. If there are 2 arrows starting from the same place, it is not a function. So let's do a couple examples of this, and then we will break, and there'll be an additional video with more examples of this particular idea. So here are 3 examples. Determine if each of the following relations are functions. If not, explain why the relation is not a function. State the domain and the range. So on number 1, they give us a graph. If you notice, that means we're supposed to run the vertical line test. There's nowhere where we can draw a vertical line and have it pass through more than one of the points indicated on the graph. So this is a function. Okay? The next thing we're supposed to do is state the domain and the range. And space is a little bit limited, but we'll manage this anyway. The domain would be the list of the x coordinates. So there are points located at -3, -2, 0, 1, 2, 3, and 4. As for the range, there are some repeated range values. If we look at the y coordinates of these points, where they are on the y-axis, there are 2 points that have a y coordinate of -1. We have one at 0. 2 of them have a 1, and 2 of them have a 2. So the range would be -1, 0, 1, and 2. The second example, instead of giving us a graph, they give us a table. Ask the same question, is this relation a function? And what are the domain and the range? So, if we look, you'll notice that in this table, when we look at a table or a list of ordered pairs, we're looking at the x values. See how there are 2 1s in the x column? That means we have a repeated x value. So this is not a function. And we have to explain, because it says, if not explain, why not? So we say, repeated x value. And if you're really fancy, you can say x equals 1. So that is not a function, and there's why. So we've got a repeated x value. Its domain is the numbers 1 and 2, because again, when we list a domain, we do not ever repeat. And its range is 5, 7, and 9, the numbers listed in the y column. On number 3, this is a mapping, so we look to see if there are two arrows beginning at the same place, and there is. See how there are two arrows beginning here at -4? That indicates that this is not a function, because again we have a repeated x value of -4. So that is not a function. The domain are the numbers listed in the domain bubble, -4, -7, and -8. Again, it doesn't matter if they're in order, so it doesn't matter what order we list them. And the range are the numbers in the range bubble, 2, 3, 5, and 6. There will be an additional video with additional examples of this if you do not follow along yet.